Hello lovely people, finally I have my hands on the Down4Sound EZY-DSP 612, and in this video I'm going to try to answer the question that everybody has. Is this a cheap Chinese junk thing or the new budget king of DSPs? So stay tuned to find that out. Before we start, just a disclaimer, I haven't bought this DSP, this was sent to me by Down4Sound. I just want everybody to know because I'm open with everything. Most of the stuff that I test, I don't buy it. Most of the stuff is sent to me for review. But if you've seen any of my previous videos, probably you know that if something is wrong, I don't hold back. And I will have a few things that I would like to criticize about this DSP. So with this DSP, I made a huge mistake because when I got it yesterday, I wanted to test it straight away. So I already know how it measures. I already know how it performs. I always shoot unboxing everything first, but in this case, and I did the measurements first. So in this video, we're gonna test it. We're gonna properly test it, all the distortion and everything. We're gonna test the analog, digital, Bluetooth, and everything else. So what I'm gonna be testing with is Quantasylum QA403. This is going to be analog inputs and analog outputs because it has a very clean DAC and ADC. You've seen this thing in a few of my previous videos, and I can compare this with the Audio Precision. It's kind of a budget version. It's a very cool thing. So this audio analyzer for the analog signals. Then I'm going to be using FIO BTA Pro to test the Bluetooth connection and the digital because this one has coax outputs, optical output, and as I mentioned, the Bluetooth. So this thing goes all the way up to LDAC. However, this doesn't support LDAC. It goes only up to aptX HD. So it's going to be a perfect test for that. And when I'm going to feed the digital input into the DSP, I will be measuring with the Cosmos ADC, which is probably the cleanest thing on the planet for the money that it costs. Okay, so let's unbox this thing and see what comes in the box. So the box is like that. Nothing special, and we have loads and loads of specs listed here in the very back. I'm not going to go through everything. I just want to point out one thing, which is ultra low total harmonic distortion of 0.05%. This is a lie. And if you want to know why, stick till the end when we're going to go through the distortion measurements. I'm going to show you exactly why. All the other stuff is not really important apart from a few things. So we have a Bluetooth 5.0 aptX HD, which is very cool. Not all phones support aptX HD, so you have to be careful what you're using. I'm using a Pixel phone, so it's going to be perfectly fine because Pixel supports all the way up to LDAC. But most newer phones will support that. However, if you're using an older phone, I'm not sure about Apple devices because I'm not familiar with them at all. If you will be using a lower codec such as AAC or SBC, you will have much worse performance. This DSP has optical and coax with digital inputs. It's perfectly because I'm going to be using it with my Joying head unit that has coax output. And probably the main downside to this DSP is that it's limited to 48K. Now, it's not a bad thing, and it's probably expected for the price because this thing costs $400. I'm not sure how long they're gonna sell it for $400 because in my opinion it is worth much more. Now all the Helix DSPs, they run a 96K natively. The Brax can go up to 192. Alpine DSPs, they're limited to 48K as well. So again, it's not an issue, but one thing to note. And all the other stuff, for us it's not really important because I'm gonna show you real world results of this. So when you open the box, we have a manual. So I'm going to be very critical and point out every single thing with this packaging. So one thing is that the manual is slightly bigger than the box, so it comes a little bit tucked away. So Down4Sound, make the manual a little bit smaller or the box a little bit bigger. We're not going to go through the manual because it's just typical, all the specs that you have, you can read it by yourself. There are some instructions how to use the mobile app and the PC software. If you want, I have two videos about this, one about the PC software and one about the mobile app. You can watch that. I'm going through every single little detail, what everything means in that. So you can watch that tutorial on my channel. But for this purpose, we're going to put put it on the side. Then we have this, and then we have the actual DSP inside. Now, I did take it out of the plastic wrap because I was testing it, but it comes like this. So another note, most of the devices that come brand new packaged with the Bluetooth thing, they do have this Bluetooth antenna. So my advice for Down4Sound as well, don't ship it with the Bluetooth antenna attached, because I've seen some pictures online, maybe it was just one, where the guy received this DSP and the Bluetooth antenna was broken because somebody slammed it on the sides. So all the devices that I usually get brand new, this antenna, usually it's packed separately in a little bag and left somewhere there. So this basically protects the Bluetooth antenna from being broken. This is just a little tip. And we have some mounting thingies. So these mounting brackets, they come like this, and that bracket fixes here on the side with 2 screws, just like that, and then you can fit it to an amp rack. Let's put the antenna back and let's go through this DSP very quickly. So the finish is black. It's matte black, it's not shiny. I do really like it. It feels quite hefty, but not as heavy. And the shape of it, I would imagine it was done on purpose just to make it look like an amplifier, so that you could put next to like a 4-channel or whatever, and it's gonna look very similar. Me personally, I don't like it, but it's just my personal opinion, so take it for what it is. Don't get me wrong, it does look good, but it's just not for me. At the bottom, we have some vents, and let's have a look at the inputs and outputs. So here on this side, we have the power, we have analog inputs and digital inputs, and the Bluetooth. So these are Tiffany RCA connectors, just like that. You can screw them on, which for this price, I don't know how they managed to pull it off, because I haven't seen any Tiffany RCAs on anything that I've personally reviewed. And this power connector, it's very difficult to take it out. There we go. So it is a typical, I don't know how you call it, Phoenix Molex plug, and it's exactly the same as you have for Helix DSPs. I did test it a few minutes ago. It does plug in, even with these tabs, it does plug in. You can use it, and you can buy them separate. So in case you lose it or something, you can buy 5 of them for a few dollars from AliExpress. Very typical, they're used everywhere. Now, one thing different about these is that these have these screws on the corners, and they were meant to do is you can screw them in just to make the connector very robust, and you won't be able to pull it out, and it's not going to shake off, because Down4Sound is kind of known as an SPL brand, so you will be installing it with big massive subwoofers that vibrate everything. That's why probably you have the Tiffany style RCAs that you can screw in, and these as well. So one thing to note about the actual connectors is that what I always like to do is use ferrules on the wires, on all the wires, but for these you really don't need it, because you can see it kind of screws in and it pinches the wire just like that. So even if you use bare wires, it's gonna hold it perfectly fine, because this actual connector acts kind of as a ferrule. So you can use bare wires, but I always use ferrules on all of my wires. But yeah, it's very nice. One thing to note about the layout, because I thought I'm just gonna hot swap the Helix DSP with this one. However, the layout of the terminals is not the same. For the Helix, you have positive, negative, remote in, remote out. And for this one, you have positive and negative on the sides and a remote in the middle. So I won't be able to use the same connect and same layout for this DSP as I have for the Helix. I will need to just rewire it a little bit. But it's not an issue because it has to do with the layout inside. Now, this little switch, off and ACC. So this is how the DSP turns on. If you leave it on ACC accessory, it's gonna turn on from the remote. However, this is weird. If you turn it off, even in the manual, it's gonna stay off. So it's like an off switch for the DSP, which I don't know why is it needed, to be honest. Then we have the power LED and the clip LED. So this clip LED is going to be for your analog inputs. If you're going to overdrive the inputs, then you're going to have a clip light. And on this side, we have optical connection, we have coax, and we have Bluetooth and Bluetooth LED. So it is blinking when you have it in pairing mode, and it's a solid light when the Bluetooth is paired. On the other side, we have 12 outputs. So this is a 612 DSP, which have 6 inputs and 12 outputs. The smaller brother is 6.8 that has only 8 outputs. On this side, exactly the same Tiffany style RCAs, which is very nice to see. Then we have a controller, we have output clip light and a USB port. So USB port is to connect the DSP to the laptop, and it's very nice that you're using, I call it a printer cable. I don't know what connection is called, but I like this printer cable. It's chunky, it's robust, you plug it in and it stays in there. Output clip, we're gonna talk about this a bit later, but basically it lights up if you clip the outputs, which is very, very cool to see. And the controller. So another downside to this DSP that it comes as this, and it doesn't have a controller with it. Down4Sound says that they're gonna start selling the controller a bit later in the year, maybe in a few months. And for me, it's almost a deal breaker, because if you have a DSP, you want to control the volume in some way. If you have it on the head unit, it's fine. If you have like steering wheel integration, it's kind of fine, but I don't have those things. And for me personally, to control the volume on the head unit is not ideal. That's why I always want a controller. Even a small pot, like a bass knob, would be perfect. So I'll have to wait a couple of months just to have the controller and test it out. Now, my channel would be my channel if we wouldn't open stuff up. So I want to open this up and show you what's inside. And yes, I'm gonna break the warranty, but I'm not too worried about that, because I don't know, I don't consider myself to be a reviewer, but if you're reviewing stuff and you don't have a peek inside and you're not trying to break stuff, you're not actually reviewing stuff. So 4 screws, the plate comes off, and then we have this beauty inside. Now, this thing, to me, it looks super, super cool. And one thing that I want to point out, probably you notice that if I hold a DSP like this, I have my outputs on this side. So this is not how this DSP comes, because when the DSP comes from factory, the outputs are on this side, and all of this is on this side. So what I did personally for my own build, I took it apart and I flipped the PCB 180, because for my install, I need the RCAs to be on this side and all the inputs to be on this side. So since this case is symmetrical, you can undo these 4 screws, 1, 2, 3, 4. You can undo these Tiffany RCAs, and then you can pull it out, flip it around and put it back in, just to have like the logo as it is, because for my install, the RCA is gonna go that side into the amplifier right there. It's just aesthetics, but to me it matters a lot. Now inside, as I mentioned, this looks super, super cool. And what I like about this is, if you see these white lines, they're separating different sections of the DSP, and I would imagine they're separated electrically as well, because if we have a look at this section here, you can see even gaps in the PCB. This, I would imagine, is to prevent any kind of noise bleed from one section to the next. And what we have here, it's very clear that you have like this section here, it's all about the power supply, because you have the power coming into this side, it goes through a transformer, caps, and then it goes out everywhere. Then the next section here in the very, very middle is all the analog stuff. So you have analog signal coming in, and through all these processes for everything, analog signal is going out. This little section here in the corner is for the future controller, so it's just to control stuff. And then on this side, we have on top left corner here is all the digital stuff that's happening. So you have a Bluetooth chip here. I wanted to check what kind of chip is there, but it is sealed with this metal casing. I really don't want to remove it in case I'm gonna break something. There's a Bluetooth chip in there, and then you have coaxial input and you have optical input. One thing to note is that, as I mentioned, this DSP is kind of for high power SPL systems, and everything inside has to be very, very robust and vibration proof. That's why you have this Tiffany RCAs, that's why you have these screws. So you can see here all these details. This, the Bluetooth connector, is glued on, so it has a dab of glue in there. This transformer has glue as well. You can see, if I will be able to show, you cannot really see like this, all these caps has a layer of glue as well, so everything is super robust, nothing is moving, just to prevent any possible vibration damage. So as I mentioned, this is all the digital stuff, and here on this side is all stuff that controls the actual DSP. So you have the USB coming in from the laptop and all the controls, everything. So this is very, very cool to see that this board is very thought out, and the layout, I would imagine, is very optimized. And when you see like this section especially, it looks very, very cool. If you want to have a look at the chips, I don't know how much is going to show. Let me try to show you. If you understand anything about these particular chips, you can write them in the comments. So you have PCM1690, whatever that is. Then we have a Down4Sound. Then we have something here, not sure what it is. Pulse something, so that's probably something to do with a power supply. Then on this side, we have an ST chip of some sort. I'm not sure what actually these things do, but if you know, please comment below. In general, it feels very, very robust, shock-proof and everything. One thing that I'm gonna really nitpick, this is really nitpicking, is the screws itself. So you can see these screws. In some DSPs, you have actual threaded holes where you can put machine bolts, but this is just with screws. Well, you shouldn't be taking them out anyway, but it's just one little thing to note. And this is being extremely nitpicky. It's not an issue whatsoever. This is how it is. This is how it looks like. Now, without any further ado, I'm gonna show you a few things that I noticed while I was doing those measurements, and then we're gonna go through all the measurements. So, idle current draw, 0.5 amp, which as an advertise, it's fine. Now what I have is I have the DSP connected via Bluetooth with the laptop, and I'm measuring the RCA output with the multimeter. REW is calibrated, so if I'm gonna play a 2-volt sine tone of 1 kilohertz, I have 2 volts on the RCAs. So here, you see the voltage. It's exactly the same. So the voltage here on all the channels, it's only 1 because it's a mono signal. This is going to show you the actual voltage that's coming out of the RCAs, which is super cool. You don't need this thing. The software itself tells you this. Super excited about this. Another thing is the clip indicator. So clipping distortion indicator here, and we have the clip light here. So what I'm gonna do now is I'm gonna run it full tilt, which is 0 dBFS. That gives me 3.8 volts out, 3.8 volts. So it's running full tilt. And now if I'm gonna try to master volume, boost it, so this is off, and I'm gonna put +1, the clip indicator comes on, and the clip indicator comes on there, which is super cool. 0, back, the clip goes down, and the clip goes down. This is so cool. Helix has a similar function on the channel gain, where you can see the red line when it goes up to clipping, and it's exactly the same with the EQ as well. So since I'm playing 1 kilohertz tone, I'm gonna grab one EQ band, number 18, which is 1 kilohertz, and I'm gonna slightly increase it. So watch the indicator, 0.1, 0.2 dB, and the clip indicator tells us that it's clipping. So everything that goes above 0 dBFS, it's clipped. So now we have the signal 3.9 volts, and it is slightly clipping. If I'm gonna go one click down, 0.1, the voltage drops to 3.8, which is this one 3.9, very similar, and the clip goes down. So the clip indicator is super accurate, and you can 100% trust it. This is very, very cool. Another thing that I want to show you is the limiter. So if I'm going to go to options, limiter, and for channel 1, so this 20 dBu is everything maxed out. If I want to limit the output, you can see 3.8 volts. If I'm going to put, let's say 10 dBu, the voltage drops to 2.7, 2.47. 2.5 volts. So if I'm going to go down to, let's say 8 dBu, this is going to be close to 2 volts. 2 volts. So if you have like an old school amplifiers that take only up to 2 volts in, you just set the limiter on all channels at 8 dBu, and then you're all set. If your amplifier takes up to 4 volts, then you just leave it at 20, and you're gonna have 3.8 volts. And this one very quick, equipment voltage, 13.2 volts. 13.22 volts, super accurate as well. So first we're going to start with the typical one, THD versus level. Now, I took this measurement and my first reaction was like, wow, can this be true? So analog inputs, analog outputs, we have maximum output 3.8 volts, something like that, as it's supposed to be. And the THD plus noise, 0.02%. This is super clean. Now, it gets better. If we're gonna go to optical, it's even lower than that. The THD plus noise, 0.013%. Now, obviously, on Bluetooth is a bit worse because Bluetooth is a bit noisy, just like that. So with Bluetooth, 0.01, which is probably like 10 times as high because Bluetooth in general is a bit noisier. However, if you remember the measurements from the EZY amplifier, the EZY Power 810, that one was hovering between 0.01 and 3, somewhere like here. So if you use this DSP on Bluetooth, it's kind of on the same level as that amplifier. But if you're using all with the digital signal, you're gonna have a much better performance. So one thing I want to point out that this measurement, you can see it doesn't clip anything, 3.8 volts, and this was taken with 0 dB on the main volume. If you go on to plus, obviously you're gonna go into clipping. So I tested optical with plus 6 dB on the main level. So just to show you is this, the master volume. If you're gonna go plus 6, you can have this, and with this we have clipping. So it clips everything above 0. I just wanted to see how much it's clipping. So this I think is like plus 1 or 2 dB, and you can see straight away it goes above. You can have 4 volts up to 1%, but it is a slight clip. Now, how do these measurements compare? Now I'm going to show you one graph that blew my mind. This is the overlay of all three. So you have analog, which is in the middle, optical, which is digital, coax is exactly the same, is much lower, and then we have the Bluetooth, which is there. Now I'm gonna add Helix DSP Pro Mark III. Look at that. This, if I'm gonna remove the analog, I'm so excited, sorry about that. This DSP measures as a Helix. Now, granted, Helix goes up to 8 volts of output. This DSP goes only up to 3.8. So you have half of the voltage, and it is as clean as a Helix that costs probably in the US like 3 times as much. I was looking at this and I was like, seriously? How could they do this? I have no idea. And let's compare it even more. If I'm gonna go to THD versus frequency, so this is a comparison between the Down4Sound and in purple is Helix. So we can see that both of them have a rising distortion at the lower frequencies, which was noted when I did the Helix review. And the conclusion was that it's still okay. Even 0.05% at such low frequencies, it doesn't matter at all, because what we want is to be as clean as possible at the higher frequencies, the top end. And you can see they follow almost identical. So yes, the Down4Sound has more distortion at higher frequencies, so for the tweeters, but it's 0.02%, whereas Helix is below 0.01. So yes, Helix is much cleaner on the higher frequencies. However, this difference, I'm not sure if it's going to be audible. I still cannot believe that this DSP measures so close to the Helix Pro. Now, obviously, the Bragg's DSPs are going to be much cleaner than that, or the Ultra and stuff. The Pro Mark III, it's not a budget option, but it's a 10 channel that has a very respectable performance, and this Down4Sound is as good. Let me show you another one. This is a 1 kilohertz tone of the Down4Sound DSP. We can see the noise is all the way down there, 135, amazing stuff. All the harmonics are below 100 dB. Now, how Helix measures? just like that. You can see the performance. Yes, we have something happening here, but the performance, I don't want to say identical, but they're so close. Yes, Helix has much lower harmonics and much less of those harmonics, especially like the fifth one. You can see the fifth one is down there, but this is such a surprise. I'm really shocked that a DSP for 400 bucks can measure so good. So enough of the comparisons. Let's go through all the measurements that we have. Analog input, as I mentioned, very clean. 3.8 volts, 0.02%, something like that. Now the other DSP, the 6.8, I believe Drew tested it and it did measure slightly worse than this. I'm not sure which inputs he was using, but the smaller brother is not as good as a performer, but still good. We see that THD, it's all the way down there, 0.02, and the harmonics are not far behind. On optical, we have a much better situation, especially on lower levels, the THD goes down. It is a third harmonic dominated, but when the levels are so low, the third or second, it doesn't matter. And Bluetooth, as I mentioned, it does have a lot of noise, which is typical for a Bluetooth, but it's good to see that THD and harmonics are very low as well. Now, THD versus frequency, as I mentioned, we do have the rising bottom end, but it's very low. The surprising thing, the THD versus frequency, it's cleaner on the analog inputs compared to the digital, the bottom end. The higher frequencies, they are cleaner on the digital. You can see here on the analog is 0.02, on optical goes down to 0.01. We have slight rise at the high frequencies, but it's nothing. 0.02% is super clean. Now, Bluetooth, whoa. Yes, Bluetooth always have problems. It doesn't matter what kind of high-res streaming it is, unless it's an LDAC, all Bluetooth are gonna have similar problems where you have a lot of noise in the very high frequencies. This is very typical of Bluetooth. You cannot go around it. But the THD, it's still low. So the distortion is low, but the noise is high. Now let's compare the spectrum. 1 kilohertz tone, this is analog. We have the noise at 130, we have a few harmonics, slightly above 100. Digital is much better. You can see the noise goes down and the harmonics as well. Now I did test coax and optical, and they do measure identical as in all the other stuff that I tested. That's why I have only optical measurements, because they measure identical, so there's no point having two of the same. And Bluetooth, yeah, Bluetooth is noisy. Very high floor noise. The harmonics are still the same. You can see these bump. They're exactly the same as on optical, just with a much higher floor noise. Now let's have a look at the intermodulation. That's the 60 and 7K tones. And we can see that we have some intermodulation problems at the lower frequencies, but it's the same with the Helix. I just don't have the measurement to show you, because when you have that rising end THD versus frequency, you will expect something like that. However, on the higher frequencies, it's very clean. But in the lower, even on this, you can see it's 85 dB and lower. It's totally fine. Optical measures slightly better, slightly lower noise and slightly lower harmonics, just like that. So we have this biggest peak, 88 or something. That's very good. And on Bluetooth, yeah, Bluetooth, again, very noisy, and it's very typical with all the Bluetooth stuff that I tested. Now, the higher frequencies, if we're gonna have a look at the intermodulation of 18 and 20K, we have everything below, that's on analog, below 76. Optical, which is digital, is much better, just like that. It goes down to 83. Now you see this chop off at 22K because I ran optical up to 48K sampling rate, and analog I ran up to 96 just because I can. But with the digital I didn't want to, because again this DSP is limited at 48, so there's no point testing a digital signal that is higher, because it's gonna be like compatibility issues and that kind of stuff. So yeah, very low harmonics, 83 dB. Now Bluetooth, yes, with Bluetooth you have loads of problems, and you can see this noise, a mountain of noise down to minus 60, which is not nice. However, the good thing is aptX HD plays up to 20K. you still have that 20K tone, because on the lower codecs, if you use AAC or SBC, this 20K tone is going to be chopped off. So it's very nice to see that it does play all the way up to 20K. Multitone distortion on the digital is very, very nice. Yes, we do have this rising bottom end, but it's not a big of an issue. What we have is 16.8 bits of dynamic range, which is very, very good, especially for the price. I cannot emphasize this enough that if you look at the measurements on their own, they are very good. When you consider the price of $400, this is amazing. And finally, the frequency response. Don't look at this bump, because I took the frequency response with the phone. I had to apply the smoothing, because without any smoothing, you have something like this, because it is pink noise, so that's fine. But the main thing is the bottom end, it goes all the way down to 10, half a dB drop, which is fine. But the most important thing is the top end. So we can see that on analog, and digital is exactly the same. We do have a slight drop of about 0.7 of a dB at 20K, which is very little, but it is there. And the Bluetooth, it does drop off slightly more, and at 20K, we're down by 2.2 dB. So yes, this DSP, as I mentioned, it is limited to 48K sampling rate, not 96. If you would have 96, then it would go all the way up to 50K. So this is one of the downsides, but probably because they reduce the sampling rate, they can have much cleaner signal. I don't know if it's connected, but it's just very nice to see. So just to go back to the distortion and this graph, as I mentioned in the very, very beginning, that on the box is mentioned that THD plus noise is 0.05%. I have no idea where they got this number, and I said that it's a lie because that number is there. And this DSP is so much cleaner that's written on the box that probably they should change that number to 0.013 or 0.02, because it's a very, very clean DSP. Now, intermodulation on the box, it was written 0.05%. So on analog, we do have slightly more, 0.06, but on optical, we have 0.046. So it's just spot on. If you're using digital inputs, it's spot on what's written on the box. Signal to noise ratio, it was written, I think, 100 dB. So we have 93 dB on analog, and on digital we have 100.1. No lie there, exactly the same as on the box. So yeah, just to put in a few words, I'm extremely surprised by the performance of this DSP, and I really don't know how they managed to pull it off for the price that this DSP sells. Summary time, and let's go back to the question that I posted in the intro. Is this cheap Chinese junk, or is this a new budget gem? In my opinion, looking at the objective measurements, this is the new budget gem of DSPs. While it costs $400, it's a no-brainer, because for competition, you have Alpine 0850X that has something similar performance-wise, something very similar functionality-wise, but it costs twice as much. On the opposite side of the spectrum, you're going to have a Helix DSP that, again, objectively, measurements-wise, is something similar to this. Helix will have much more functionality wise, but the price is probably gonna be 3 times the difference. Now, yes, I cannot comment about the longevity, about the robustness and everything about this DSP because I haven't tested in the real world yet, but I'm gonna put this in my car, I'm gonna test it. But so far, from objective measurements only, this is the new budget king of DSPs. You're not gonna find anything on the market that performs as well for the price tag of $400 as it stands now. While we're talking about prices and buying stuff from Down4Sound, I do have an affiliate link. I'm going to leave it in the video description. If you're going to use at the checkout code RAWCAT88, it's going to help me out quite a lot. So if you're going to buy this DSP, please use the affiliate link, help me out as well. But I really don't have any words. I have no idea how they managed to pull it off, how they managed to get such a good product for such a low price. And yes, it's made in China, all that stuff, blah, blah, blah. I personally do not care where it's made. I care about how much it costs and how good it performs. So I would like to hear your opinions as well. And for now, that's been it. Thank you very much for watching, and I will see you in the next one.